This tutorial is about two-dimensional plane stress and strain. So in this particular example here, a steel bracket is fixed to a wall along its left side. A tensile force with a total magnitude of 5 kN is applied to the right hand side of the bracket. So from this example, it's a three-dimensional sketch. So we may simplify in two-dimensional as the thickness is constant along the bracket. And also we found that a symmetrical about its horizontal position may apply. So given that Young modulus is 210 gigapascal and the Poisson ratio is 0.3. So first, we are going to create our part by double-click on the parts and we name it as plan. Modeling space is 2D planar, type is deformable, and the base feature is shell. Approximate size is 5. So in this case, we have sketched the bracket with the symmetric horizontal position. So next, we are going to define our material. So in this case, we double click on the materials and the edit material window will appear. So click on the mechanical elasticity and followed by elastic. So we may specify the Young modulus and Poisson ratio in the example here. So the next part is double click on the section assignment and select the whole plate and click continue. After we click continue, edit section assignment will appear. So click on the section and the create section window will appear. So we are going to select solid with homogeneous. This is because the bracket have the thickness and this will specify the thickness we require. So after that we click continue and the edit section window will appear here. So we are going to select we take the plane stress strain thickness and specify the thickness which is required in the question. After that click OK. So once you have clicked OK, so the edit section assignment will appear here again. So in this case, the type and the material is specified and we click OK. So once we click OK, with the bracket will appear on your screen if everything is properly defined. Next is to double click the instances and the create instance window will appear on your screen. And we are going to click OK and the plate will display in blue color. So the next step is to define the step. The step is to double click on the step and the create step window will appear. So we select the linear perturbation and select statics. This is because we need to create before we create our load, so we need to create this step first. Click continue. After we click continue, and this step window will appear here and click OK. So next is to define our boundary condition. So the first boundary condition is the symmetry about the horizontal axis. So select mechanical and the symmetry, click continue. After we click continue, so we select the two horizontal lines as indicated in the red arrow and click done. After we click done and the edit boundary condition window will appear, so we are going to select the Y symmetry. This is because the bracket is symmetry about the horizontal axis and it will only move in the horizontal direction but not the vertical direction. So since it's not move in the vertical direction, so the U2 should be equal to 0. So therefore we select Y symmetry and we follow by OK. So the next boundary condition is to apply the fixed point. So we name it as fixed followed by symmetry and click continue. So we are going to select the far left hand side of the bracket, and in the edit boundary condition window, we select the encaster. This is because all the XYZ direction on the far left hand side is fixed. So therefore we select encaster and followed by OK. So the next is the loads. So since we are going to apply the pressure on the far right hand side, so we select pressure and click continue. So select the vertical line of the far right hand side of the bracket as indicated in the red arrow, and we click done. After we click done, so as we remember in the section assignment, so in the section, so the thickness we specify is 0.01. So therefore the pressure is, we know that the pressure is force over area. The force is given in the question is 5 kilonewton, and the width is 0.01 and the thickness is 0.01. Therefore, the pressure is 5 megapascal. So the magnitude we specify in the edit load window is -5 E6, and we click OK. So the next part is to mesh our bracket. So we click on the parts and the global seed window will appear. Why I select the global seed window? Because I specified the element size as 0.005 meters for the whole structure. If you want to specify more element in the curve, so we may click on the seed edge and specify the element number we require, and after that we may define the remaining line number of elements we require as well. So in this case, so I'm going to use global seed. So the global seed dimension element size is 0.005 and click OK. After this step, so we are going to define what is our element type. So select the whole plan and followed by done. So the element type window will appear on your screen. So in this case, so we are going to select plan stress and untick the reduce integration, followed by OK, and finally click done. After that, we are going to mesh our bracket and click yes. So in your screen, it will appear the mesh element. So you will realize that the mesh here is randomly produced because we have selected the free mesh technique. So the next step is to create our job and submit the model to perform our analysis. So after the job is complete, we may review the result. So the first result is Wurmser stress. So we will realize that the maximum stress will be occur at the corner of the structure. So this is the plan stress we have defined in the element type. So the next example is we are using the plan strength. So in this case, we know that the plan strength is should divided by a unit thickness equal to 1 in the section. Okay, so we go back in the section and we change the plan stress or thickness to 1. And we also know that the pressure of the structure is force over area. The force is 5 kilonewton, the width is 0.1, and the thickness we specify here is 1 rather than 0.01 because in the edit section, so we specify the thickness as 1 unit. Therefore, the pressure is 50 kilopascal. So in the load condition, we are going to change to 50 kilopascal. So the next step we are going to change is the element type. So we are going to select plan strength and followed by OK and done. So everything has been set. So you may create a job analysis and perform the result. So in this case, so I'm going to create a new job and name is at plan strength. This is because the previous solution will not be override. So submit the job to be analyzed. Once completed, we may review the result. So in this case, the result is displayed as a wall misses again, but the two differences between using the plan strength and the plan stress is the magnitude of the two examples is different by their thickness. So in this case, for the plan strength, so the thickness is considered at 1 unit thickness. Therefore, the power of the wall misses stress is 10 to the power 4 rather than 10 to the power 6. So thank you.